Oh yeah, that this thing. Okay.
And then you're never here, so, and you're not
Angela.
Slowly transitioning back. I'm like, sometimes it's just like,
Oh, and one more page I want to see. Yeah. It's okay if I grab that like after weather. Yeah, absolutely. Yeah. I get rid of any of these other ones, Michael? Go to the right, yeah.
that's why they say like, don't make you browse a lot. That's why they say don't browse.
Such a clown.
Yeah, I still want to borrow that more recent papers that kind of go off. I don't know.
Okay, welcome to our weather discussion for today. I thought I'd have more time to put a little bit more of a post-mortem together for last week's blizzard in New England, but I didn't. So there will be a few things that I want to mention today about that. But here's the Snowfall Reports Map. This is from the Northeast Regional Climate Center at Cornell. So it's really kind of a nice site. The peak snowfall for that event was 30.9 inches near Stoughton, Mass., which is just to the southwest of Boston. New York City had 25 inches near near Orient, New York, and Suffolk County. Caribou, Maine had 22. Philadelphia, places in the Philly area had 21. That doesn't show up really nicely on this map. That's kind of, it doesn't show up so nicely on this map. Gray, Maine had 20 inches. Wakefield, Virginia had 14, and so on. But you can see this was a coastal event, and that was the forecast issue all along during that week. Is it going to be offshore? Is it going to be onshore? And it ended up being onshore. Michael,
Yeah, I was going to say that those stations like Wakefield and all that, those are just the Weather Service offices. It's the actual location is like Ocean Pines, Maryland.
Oh, that's a different, okay. I didn't know they were making that distinction. I wasn't paying attention. Okay, so, but you can see, I mean, if this is where I grew up as a kid. I mean, this was like this was ground zero for this event, which is really exciting. And I think in Peabody there was 21 inches of snow, and there was 20, you can scroll up a little bit, Pete, to get away from the map just for a second. Some of the, a little further. Yeah, here's some of the records. 23.6 at Logan Airport was the January 1st all-time rank. I don't really understand this because I thought they had 24 something in 2003 in February, so I'm not really sure I get that. But anyway, it was among the top snowstorms of all time. Providence broke its all-time record, and then you can see some other places came close in the top 10. Pretty interesting events. I'm not sure what this is. Let's see. For the month of January through the 29th, it was a snowy month in Providence. But again, not top 5 necessarily, but top 10, and then in many other places. So it's been a totally different winter in the eastern United States than it has been here. We've struggled to see any snow, let alone accumulating snow. I mean, really, it's been difficult to even, I wish I'd kept track of the days on which it has snowed. I think it's been less than 10 days where we've had snow flurries or accumulating snow. And that's really terrible.
Do we see that from Ed's, from the SEO?
I don't know, does he keep track of days where there's at least a trace?
It shows those tick marks that things will go up in
Okay,
there.
let's see if we can't quickly get that. But the broad point as we're looking this up is that we just haven't had many such days. We had a 3.6-inch snowfall December 28th and the 4-point-something fluffy stuff the other day, which I think is about this one here. So I don't know, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have a memory for this, don't I? 11 times it snowed this winter. That's terrible. I feel like I'm living in Miami. Or well, maybe not. Although yesterday was Miami's anniversary for its all-time lowest temperature, 27 Fahrenheit. I feel really bad. Okay, so that's kind of a rough review of really what went down in the Northeast United States last weekend. And one thing that doesn't show up here, except in words, is that the winds were really strong. There were a lot of places that had gusts over 50 miles per hour, and some on Cape Cod were nearly at 90. So it was pretty unbelievable. That was not unexpected because the storm developed so rapidly, and especially on its western edge, the pressure gradient was extreme. One thing I think the press maybe overdid was how cold it got behind it. And we're talking about the East Coast is freezing after the storm, and the temperatures weren't really that cold. I don't think there were even below zero temperatures in the New England states, the southern New England states. So when it gets below zero there, it's notable. It doesn't happen that often. But it didn't do that in the wake of this storm. And then today we'll see that they're contending with some more wintry precipitation, I think freezing rain on top of whatever's left of the snow. So it's really kind of ugly today. I want to show you just a couple of things from, I took the GFS analyses every 6 hours from this event from 26th of January to the 31st. So if anybody wants to look at those data, they've got all the basic state variables and things that you can calculate from them in it. So that's readily available if you're interested in having that data set. What I did on top of that was I wanted to invert for the QG omega in all of its various species and see how that came out in this storm. So what I'm going to do is kind of sit at the podium for just a minute, show you a couple of things, and then get back onto the discussion. And I'll try and keep my voice elevated while I'm doing it. So the first thing is, where's my, what's this?
That's me, here. That's like the link.
So where's me?
It looked like you had some sort of error that popped up. You were running it.
Okay. Oh, I have some script going. That's easily fixed. If I could just type. Okay, so this is the total 700 millibar QG omega over the region at, I think it's 12Z on the 29th. So this was Saturday morning. And these, I'm showing you only where it's rising. So it's kind of an interesting structure. When I first saw this, I thought, whoa, I don't really know what to make of this, but you'll see, I think there's a way to make sense of it in just a minute. So there's this kind of bullseye of strong upward vertical motion off of Cape Cod, and then there's this linear, quasi-linear feature along the coast. And this is as the snow is beginning to fall in southern New England, or maybe an hour or two after it started. So it was already snowing along the coast by this time. Maybe I got the same problem. Yep. I don't really understand. What?
Did all the time.
It's not going to work. It's going to take too much time to resurrect because it's going to its own data set. Sorry about that. I'll put it together for another time. One last thing before we get on to our regular discussion, though, Pete. I had my cold pool analysis that I wanted to talk about. I'll just tell you the gist of that story. Go ahead.
Before you move on,
Yeah.
what about these low ratios for the snow? The low water liquid to snow ratio. Has that been reconciled? Was it really that low, like was reported?
I don't know. I can say this. It doesn't.
Or high, I should say.
Yeah, it doesn't usually snow in Boston at 18 degrees Fahrenheit. That's rare. So,
Yeah.
And
Yeah, I wonder how much the blowing snow had an issue in some of the reports. Is that what you're referring to, just how
Well,
unusually
they
low
were
some of
showing
the-
that the typical ratios were 30-1, 35-1 ratios between snow and
Yeah,
liquid.
how suspect would you be with that, with the blowing snow issue? I don't know how well.
But if you believe that, then all these big numbers you're looking at here were really only about an inch of liquid.
potentially that's true.
If
You
you
don't know
believe
that.
the-
Yeah. I'm
Yeah,
a little
that's right,
skeptical.
that's what I'm asking.
Yeah.
That seems crazy to me.
Yeah.
There was, I think somewhere on this page, there was actually mention of liquid equivalents, but we don't want to
Yeah.
spend any time doing it now when I'm searching for it, kind of like you would be needle in a haystack. But I can say that that was an unusually dry snow for this part of the world. When it snows heavily, it's not usually this kind, Wisconsin type snow.
Yeah.
So, maybe it got a little bit of extra press just because it's unusual, but I don't know what the actual liquid equivalent
Well,
was.
usually when you have a big, well, I think in particular, when you have a big snow, it's usually a low ratio, 10-1.
Yeah.
Because it's usually so much liquid in the system, but to get this much snow on the coast,
Yeah.
and have a 30-1, 40-1 ratio is outlandish.
Yeah, it's pretty wild. In the flow, most of the strong winds were northerly winds. They didn't have much of an easterly component, which is another unusual aspect for this event. I mean, on, the elbow of Cape Cod, a northerly flow comes across Massachusetts Bay. This is a lake effect enhancement there, but everywhere else that often gets an ocean effect did not this time. So this was all going on in that western cloud head, which I think I wish I had the satellite to show you, but I remember we were talking about it on the weekend, how poorly presented this thing was. It just didn't look like it was put together at all, except way out east was the big cloud head, and the stuff hanging along the coast, dropping all the snow, looked like it was gonna fall apart in a moment. But it didn't hang around all day and snowed heavily, so, it's a lot of mysteries in this one.
One thing that's different is a lot of the snows are focused and they're large because of a coastal front.
Yeah,
That sits
yeah.
there, and the lifting of the marine air over the coastal front. I suspect that wasn't so much the case
I
here.
think you are exactly
Yeah,
right.
so when I had my hand up just before you said
Yeah.
that, I was actually gonna say, I think the coastal front was actually east of Boston.
Yeah.
in this event.
Over the
To the
bay.
extent that there was any sort of coastal fronts, I think there were northeast winds in Provincetown and places on the Cape,
Yeah.
but it was more northerly from, like Portland, Maine down to Boston. They were in the north, they had
Yeah.
a strong northerly flow.
Yeah, and the front is weaker if it gets over Massachusetts Bay. It stays together if it's over land,
So
so.
it's probably a deeper lifting pattern than is typical on the East Coast storms, and that's why it was dropped.
And that's what I was trying to show you, but if things went
Yeah.
sideways, and I don't want to waste the time, but I can tell you what looked like a kind of a sort of strange distribution, the big bullseye off of Massachusetts Bay at 12Z, and then the linear feature along the coast. You can show quite easily that the linear feature is tied to the frontogenetic activity quite dramatically, and then the bullseye is connected to the upper wave. So the development of the cyclone is going on to the north and east of the strong frontogenesis, which is kind of a weird orientation, but that's the way this thing looked like it behaved. After 12Z to 18Z midday on Saturday, things looked a little bit more normal, and by 0Z on the 30th, they really looked normal, but they were up in the Gulf of Maine then, and things were dying down in southern New England.
Did you see any reports of the crystal habits that were formed?
Oh,
I didn't know.
can I actually pull something up really quick?
Yeah.
So, I don't want to divert this too much, and I
It's
haven't
not
looked at
diverted
it
at
that
all.
much,
It's not
but,
diverted.
let me,
Quick shout out to the Sun Prairie High School Weather and Climate class that's tuning in.
oh,
Good to
nice.
have them.
So, can you all hear me in the back? I'm not used to not using a mic. Okay. Is it on? Oh. Don't have to yell. So I very briefly mentioned last week that there's a major field campaign that was going to fly this event, and I really haven't looked at this too much, just some quick glances, but there's a few things. So the crystal habit question is a loft. So I didn't look at it what was at the ground, but the P3 was doing in situ flights for this, and I'll just show you a quick a view of. So John, you mentioned the linear structure, and I
Yeah.
wanted to show you. Let's just look at Boston. Let me go back. That was the 29th, right?
Yeah. Pretty cool.
So let me. Hopefully this will load quickly. No, this isn't the time. No, I should have set this up ahead of time, but let me show you really quick the flight track. So there were 2 aircraft. The ER-2 flies higher and had a radar, and then the P-3 did some in-situ measurements. So you can see during this event, the P-3 was actually able to fly on some of those bands that were offshore to try to look at some of those characteristics. So just to give you the spatial context, roughly of looking at, so initially there were multiple bands, and then later on when they were flying, there was kind of one long linear band that moved on shore, and you saw some of the heaviest snow rates. But this is more just eye candy. But the first thing I wanted to look at was some of the in-situ probes for crystal habits. And the short version is you didn't really see a lot of large amounts of aggregation. I mean, there are a lot of things that would suggest really small particles in that really dry ratio, although I'm still suspect of the 30 to 40 to 1. Anyone's able to go look at this, and I plan to look at it a lot more. I just haven't had time. But we can look at it isn't the most user intuitive, the P3 CPI images. So for those who haven't spent time looking at his particle probe data, you can get, I don't have the flight level on here, but you can get a sense of some of the plate structures. If you go a little bit higher, there are a lot of bullet rosettes. There's a few really beautiful plate dendrites that you can capture, but the point I'm making is even though this was a little bit higher up, there was really evidence that would support some of those drier ratios, and you didn't really see a whole lot of aggregation once you looked at some of the flight levels. So this is...
So that must, that's really interesting, because you would think that aggregation is the way these things are getting to the ground, but this sort of suggests that there's just so much vertical motion.
Yeah.
That you're just dumping the water out even without aggregates, and it's just coming down in small crystals.
Well, and I say that though with one caveat that, I'm not sure exactly when they were flying relative to some of that heavier band that happened a little later on the coast. But if you look a little bit, hold on, let me find this real quick. So the HBPS looks at some of the larger particles, so this is always a good one to look for some of the bigger aggregates. So it's a completely different scale, but even that, hold on, let me pause. Is there a scale on here? No, there isn't a scale. This is what the joy of looking at.
There's some.
There are some. You can see some, but these are, if you were to look at this at some other events, they're quite small. So it's not like there's no aggregates.
They look like dendritic aggregates, like you get in the Rockies.
Yeah, but they're not quite big, and there's not a lot of liquid water.
Yeah.
So anyway, that's just a slight aside, but if you're not aware of this, and there's so much valuable, on QC data here that start to peruse through.
Awesome.
If anyone's interested. And then the aircraft, just because I can't not show the radar. Let me pull this up really quick. Oh no, wait, it's under the aircraft. So there's multiple frequencies of radars that we're flying, and the flights, let me go back. They flew yesterday too, so I haven't looked at that yet. Oh, it's not up there right now. All right, I'm not gonna fiddle with this too much, but anyway, there's a lot more to look at. Maybe we can talk about this later. But I just wanted to address that comment as something that you can look up through some of this data. Yep.
That's really cool, Angela. I have to show that. And I can say anecdotally, I guess the snow stung your face, which is another rarity in New England. It's not so rare here when we get a really good windy snowstorm. You go out and you feel it stinging you because it's needle-like. That was true on Saturday in New England.
There must have been some momentum in the particles, meaning they were probably not as low, a higher density, smaller particle if they're stinging your face.
Well, but the wind was blowing 30, 35, so.
And that's
the
one
difference.
other comment. There are a lot of sounding crews out trying to get, and if you read some of the sounding logs, there's 3 failed attempts. They're trying to blow it up in the hotel, and any data they got was pretty miraculous, just how windy it was.
Unbelievable.
Yep.
Yeah, so I think it's the wind that made it
Yeah,
sting.
that's.
That's right. John, just one final comment on this, for me on this, with this respect to the storm. The development that we saw in the models with the cyclone kind of beginning to emerge right off the North Carolina coast, or just south of it, by 0Z last Saturday, was pretty much right on target.
Yeah.
And so the development of that initial cyclone, and then everything else, I think was, again, there were some variations in the track between models, but I think it was pretty much a decent forecast.
Yeah, I think it was. It was pretty darn good forecast.
It's impressive what models do today compared to 30 years ago. I mean,
I agree. Oh, it's another world.
Incredible.
It's another world.
Yeah.
And it makes diagnosing the output really fun, because even if it's kind of a wrong forecast, I've said this many times, the models created something that was realistic. Maybe not the actual reality, but you're never looking at something that's just kind of crazy, which is pretty fun. So I wanted to go next, Pete, to the cold pool just for a second. We had, for the first time in 3 winters, a day where the aerial extent of the 850 cold air was greater than a standard deviation above its calendar day average. This hasn't happened since the winter of 2018-19, and this was January 29th around the hemisphere. And so look at what's happened over this period, over the month of January. We were the 9th warmest from December 1st through January 12th of all time, 75 years now. 8th warmest after 10 more days, and then the bottom fell out. And we've had not only a snowless winter, but no opportunity for any records. So there's no hardware coming at the end of this winter, and that's frustrating to me. 12th warmest through the 31st, and then just 3 days later, 14th. So I guess we don't very often have temperatures get above the calendar day average or after February 1st, at least not in the last several years. So this is the time series for this year. It's struggled to get above average until the end of January, and then it went way above average, and it stayed there for more than a week around the hemisphere. So that's kind of interesting. I think it'll probably end up 10th, 12th, 13th warmest of all time. But still, so that's all I wanted to say about the cold pool. I did, some years ago, I looked at just a region around the Great Lakes and added up the area of the -5, -10, -15, -20, -25 to get a daily value of that. And then you can construct a probability table that says, depending on your calendar day, how likely is it that you're past the coldest winter day by that measure. And we're well past now the 65th percentile or something like that. So it's about a 66% probability we've already seen the coldest day, at least at 850, over the Great Lakes region for the winter. But, every winter is different. But anyway, there's some solace there. Been a cold recent stretch. Okay, let's go back to our satellite movie over continental U.S. if we could, Pete. I don't have it loaded up, so we might have to just drive it. So the weather story of the day today is this extended cloud streak across the eastern United States with feet all the way into the western Gulf of Mexico and arguably, as you'll see on the infrared, arguably the eastern Pacific, tropical Pacific. And then it wraps up, we'll see it better in the infrared, wraps up into the circulation of this cyclone just off the coast of Greenland, where it's still, as you can see at noontime, still dark over much of the island, so we're still in the wintertime. And desperate cyclone up there. And some light cloudiness over us. Maybe we'll see a flurry today, but that would be the 12th day of the year, I suppose, that we saw snow, but I don't think we will. And in fact, I don't care. I don't care. So I'll just say that,
So John, is the headline, John's market gives up on winter?
I don't care. I mean, I'm disheartened by it hasn't been warm. If it's going to be no snow, we might as well be the warmest year ever, or 850. I'm disheartened. So here's, we'll get off to the west coast in a minute. Can we look at the infrared feed just to highlight that cyclone off of Greenland? As connected, look at how that's connected to this whole thing in terms of the cloud mass. So it's really, and that's a compressive cyclone. I don't know what the sea level pressure is, but it's probably down below 970 easily. So category 2.5, maybe tropical cyclone. Yeah, you see one every 4th or 5th day up here. We can't keep track.
But you notice how you want to compare it with a mid-latitude cyclone with a tropical cyclone.
You know why I'm doing that though, right?
I'm not really sure. But
Yeah. And then a beautiful structure here making its way inland over British Columbia and Saskatchewan. We'll take a look at that from the west coast view. I think some of this might just be a perfect angle to make it look like a beautiful wrapped up cyclone. It doesn't quite look like that, I don't think, from the western view. It's a little oblique here. And then we'll see what's going, there's another storm off the Aleutian chain. Before we go out there though, this is the one I want to see too when we go to the west coast. Before I go out there, can we take a look at the radar across the country? The lower 48 and adjacent waters. So there's our radar summary, and there's a lot of information in here. And earlier this morning, this line of what looks like at least modestly convective weather across the Carolinas and southeast Georgia was better put together, you'll see, at the first time. So that was a little bit better put together than now, a little split up. Then there's a secondary line, arguably, that gains a little bit of integrity in terms of its structure as the day wears on, and that's the one that's kind of moving just south of Atlanta. And then the same lack of clear identified structure across this feature that's racing across New England. One thing you can see, though, is all of the stuff to the east is speckled with yellow and orange and some red, indicating probably a lot more liquid in the clouds or in the precipitation, and then it's a lot more fuzzy back to the west where it's undoubtedly more snow. So there's somewhere in between, it's kind of a mix. We'll take a look at the surface map in just a second to identify those boundaries up in the northeastern United States. A little bit of precipitation crawling in across the Olympic Peninsula into the Puget Sound region. That's really the only other story in town. This right here, I don't suspect means anything. It certainly doesn't to me. We might see a flurry, but I doubt it. So, but we had this nice lake effect band in the northern part of Lake Michigan. And I think it looked better earlier in the day, a little bit longer. But we've had a couple of nice bands. Last Friday we had a good one too, and there's probably been some in the interim during the week. So that's really nice. Short parallel band. Okay, let's take a look first at our big surface map, Pete, and kind of take a tour of the country. Then start in New England. Look at this. Freezing, well, sleet in Boston, 29 over 26. It's 42 in heavy rain at Chatham. So there's a pretty decent temperature contrast, not really a boundary. The winds are about the same. And then it's even sleeting at Portland. So the whole coast is sleet. It's raining in Nova Scotia, freezing rain further north on the island. A little bit of light snow in inland New Brunswick, but at the Bay of Fundy, there's sleet, and it's not snowing in Prince Edward Island. It is a little bit further north in Newfoundland. In New Brunswick. And raining on the coast, 51 in Atlantic City. That's really warm. 36 at New York City, 65 near Salisbury, Maryland. And then it's a lot cooler inland. It's 39 in Washington, but moderate rain. And so you can tell a big temperature contrast. Look, it's 78 degrees here that's north of Wilmington. I don't think it is Wilmington, but that's Wilmington. 74 over 64 on February 3rd. That's unbelievable.
It was in the DC Baltimore area. It was already, their high temperatures occurred earlier today with, I think, 55 to 60 between 3 a.m. and 6 a.m.
Yeah, it's remarkable. It's 79 over 67 in Miami, 71 dew point at Key West. These might be the earliest 70 dew points I've seen. But I don't pay attention to that, so I should be careful.
They were responsible for a small tornado outbreak in Alabama.
Oh, that's right, yeah, a couple people died,
That
unfortunately.
moisture return had a couple of tornado warnings.
Yeah, I think I read there were a couple of fatalities. In fact, no, that's terrible.
But during the week, it was actually cold in Florida, right? I mean,
Yeah,
There were actually
iguanas.
30s in Florida.
Yeah, they were talking about iguanas falling out of trees in Miami on Tuesday or Wednesday. I guess this is a real thing, right?
Yeah, that is
Sure, the size of house cats are bigger. I mean, they taste like chicken. I mean, there's an opportunity.
Poorly invasive.
Well, that's what I've heard. I can't say that I know. Snow in the Ohio River Valley, snow over much of Ohio, and then snow in western Pennsylvania, not surprisingly, and the same in western New York State. We saw that hinted at in the reflectivity. And we're just cold and dry here. It's been interesting that way. And then out west, not any organized weather. It's not particularly cold or particularly warm anywhere, and then there's a little bit of light precipitation on the coast at Quileute, and probably in other stations around the Puget Sound. It's showing up only on this resolution at Quileute. And it's chilly, 44 over 44, and that's a day where you can't see 10 feet in front of you, and since you're in Quileute, you don't care. But, you know, it's a little bit depressing. Okay, let's go to the upper level chapter, if we could, Pete. We'll eventually get to the west coast chapter. Try to keep in mind what we want to do. So this is 12Z at 500 millibars this morning. It looks almost just like last Friday's map. Just big upper trough centered at about 100 degrees west or 95 degrees west, with a couple of features at higher latitude that are impinging upon its boundaries. Here's a really nice horizontal baroclinic zone at 500 millibars over the chain of lakes in northern Canada. This looks almost like the Shapiro-Kaiser conceptual model. This is where these upper fronts come from, and they dig down in the northwesterly flow. This one is characterized by geostrophic warm advection in cyclonic shear, which tends to do the opposite. The air on the warm side rises and the air on the cold side sinks, and that tends to eradicate the horizontal temperature contrast by tilting. But they're always worthy of paying attention to because they're really such interesting features, these upper fronts. There's another piece down here over the Dakotas that's fairly sharp. Mine is 41 at 500 millibars at International Falls. I would guess that it stays about that cold, maybe like minus 36 or 8, all the way to the border with North Dakota, and then it's warmer than minus 30 by the time you get into far eastern Montana. And that one maybe has a potential to turn into a little upper vorticity maxima of some import, and then round the base of the trough and add to the interesting weather that's already going on in the northeast United States. The one thing that works against, very much like last weekend, one thing about last weekend's storm was it was very progressive. It started snowing in Boston around 4 a.m. and it was over by 10 p.m. And there was no chance for the thing to wrap up and kind of sit over Massachusetts Bay as a deeply occluded cyclone. And that's because the flow on the eastern side of the upper trough is so strongly stretching and deformative. So anything that gets its way around here is just going to be moved rather quickly to the north and east without any chance of really building out, even with the big cloud head, without building out some sort of an upper cutoff. And that's the nature of the flow just today, just like it was last Friday. Can we go to 850, Pete? So at 850, you can see, we already saw evidence of it in both the precipitation type across the coast and then a look at the surface map. Extraordinary temperature contrast exists even at 850 as they do at the surface. There's not much of a cyclonic circulation structure here, but there is a strong, a little bit tighter baroclinic zone over northeast Maine and New Brunswick than there is when you trail further to the south and west. The winds are about 160 degrees different across the baroclinic zone from Virginia to Cincinnati and other similar places. So there's frontogenetic activity for sure going on along this baroclinic zone. I'm not sure, and this is about a 90-degree wind shift from Sable Island to Portland. So with a more intense baroclinic zone and similarly strong confluent winds, stronger frontogenesis here, and so maybe heavier precipitation being forced by those dynamics up in the Gulf of Maine and then down over the Appalachian chain. But similar types of things going on in both of those places. In the absence of a really obvious cyclone, one relies entirely on the linear vertical motion forcing that comes from the frontogenesis. And that's reflected in the radar. We had our sort of nascent, perhaps upper front over the Dakotas and eastern Montana. That's reflected not as an upper front, but just a baroclinic zone here, really cold air in the interior, banking up against the high terrain. So underneath what might be an upper frontal structure, there's also a baroclinic zone. I think they're involving different potential temperature zones. And so see how this whole thing evolves. This is pretty chilly air. Unusually cold again in Texas this first week of this February as it was last year. Not quite as bad, and there's not as much precipitation, so there's no ice burden on all of the power lines and some of the other structures that keep people warm when unusually cold conditions invade the state of Texas. Okay. Here's a reflection at 850 of that circulation we saw in the satellite off the coast of Greenland. That's a pretty decent cyclone with a kind of an occluded looking structure in the thermal field. And the height is down well below 1,140 meters, so that's a deep cyclone. And you can see, before we go to the west coast satellite image, a pretty decent cyclone off the far northern coast of British Columbia, and then another one near the end of the Aleutian chain. Neither one has a very obvious baroclinic zone. This one could say, well, of course it won't. It's trying to make landfall across high terrain. This one here, why it has no baroclinic structure is a little bit less obvious to me. It may just be that it's late in its life cycle. I think it presents itself as such a storm on the satellite picture. So let's go there next, Pete. Oh, wait, 300 millibars. And then 200. I want to see what the jets look like. Sorry. Yeah, not surprising. So a roaring jet along the east coast, it would be nice to know, oh, we can do that. Which one is which here? Is there a polar and subtropical jet involved in this whole thing? So maximum wind speeds at 300 are in the 175, 170, 172 range right here in the core of this jet. This is 166. So everything's around 170-ish in the core there. And then here's a flow from the northwest. The southern end of it has the right sort of situation to maybe encourage the development of an upper front over the Dakotas with warm, cold air rising here and warm air sinking here. That's exactly what you want in the middle troposphere. So that's a jet exit region circulation, enhanced by being perhaps upstream of the trough axis. Up over the chain of lakes in Canada, it's a little different. You're downstream of the ridge, so there's a broad region of subsidence. And then superimpose that on a jet entrance circulation, then you have strong subsidence over here and weak ascent on the warm side, and that's eradicating the gradient. Let's see what it looks like at 200 millivolts.
Elton, did you have something?
Oh,
I was
sorry.
gonna say, I don't know how often I've seen a northeast wind in New Mexico at 300 millibars like that.
Yeah. So it's sort of suggesting that there really ought to be a more obvious curve in the flow, anticyclonic curve there than is drawn. Yeah, I agree. That's very interesting. Can we go to 200 feet and see what this jet axis looks like? So here is I can't read the number, that's 179, I think. So this is a higher wind speed at 200 millibars over, where are we? We're over New England at this point. And weaker ones at 200 millibars over the southeast. So that's interesting. This means that maybe the core of the subtropical jet is up to the north, and what's trailing back behind here is not so strongly subtropical. I don't have independent information to confirm or deny that. And here's a little stubbier looking jet at 200 millibars with, I think, weaker winds than we saw at 300 in that case as well. So it's interesting, potentially worthy of further interrogation. And then finally, let's go to the satellite movie feed on the west coast, and we'll look at the infrared. Thanks. And this is the last 6 hours. That really does present itself as kind of a beautiful structure, doesn't it? But I think you can see what I mean. The western cloud head gets kind of ripped apart when the whole thing goes on shore. It doesn't really maintain that nice-looking cyclonic textbook cover structure. But there's high clouds over much of western Canada in association with the progression of this disturbance. And we saw an upper trough at 500 and 300 millibars tied to it. Not much baroclinicity at 850, but I think I can understand that maybe that's because it's gotten eaten alive by the orography. And then our cyclone here at the Aleutian chain just looks, it really does look like it's late in its life cycle. It's decaying to nothing in 6 hours. So it looks really nice at the beginning, kind of wrapped up, but it decays very rapidly. It's just got nothing to adhere to anymore, no thermal structure to keep it active as a cloud producer. And then something maybe trailing back to the south, right, and a little hint of a concavity in the flow here. Maybe there's another upper wave that we couldn't quite see or didn't draw our attention to.
Question, where's Midway on there they've been talking about the last couple of days?
Midway is midway between the U.S. and Hawaii. So here's Hawaii. I think Midway is about
Midway
right here.
Island.
Yeah, Midway Island's about right here.
About right there?
Yeah, somewhere in this longitude band.
Yeah, because they've been having extreme winds for the last
It's a
couple of
bad
days.
ASOS sensor.
Oh, is that right?
It's not really windy.
Oh, okay.
It's a bad sensor.
Oh, is that what it is?
Yeah.
Okay.
Okay, so that's all I have for today. If there's no comments or questions, I'll turn it over. Ian.
Well, I was just gonna say for some high-hand, you check out the close-up of Lake Superior right now.
Okay. Oh yeah, that's nice. Lots of little swirlies over Lake Superior. What a horrifying environment. The water is deep, unforgiving, everything's cold, and you get, look at these swirlies up on the east coast. That's really neat. Yeah, that is very cool. Thanks for pointing that out.
Is that a
Ian.
band in the middle of the lake?
Yeah.
Yeah, right in there is one.
We got
right?
Michigan too.
One on Lake Michigan.
Yeah.
And the Lake Michigan band, the northern part was still showing up in reflectivity. The southern part apparently wasn't.
Probably too shallow.
Yeah, maybe, is that right? Yeah.
There were some interesting mesocyclonic structures in the Michigan band on radar earlier this morning. too.
Is that right?
Yeah, it's pretty neat.
I'd like to think if you're a Michigan tech student, you're sitting in class waiting for that band to reach Mount Bohemian and out in the deep. Well,
Yeah, that's very interesting. Okay, thanks.
Can we put on a satellite?
Thanks, John. So what we're going to briefly look at is, we'll start off with a satellite image for North America invisible. And one of the things we're going to concentrate on is, I mean, this, you can see, you know, that band of cloudiness that's marked the leading edge of the cold air that's advancing across the Gulf of Mexico. And we're going to look down into parts of Mexico along the Tehuantepec Peninsula, which is this spit of land, this isthmus that connects Mexico to the Yucatan Peninsula. And we're going to be looking at what's going to happen shortly in the Chavela Pass, which is just located near the mouth of the Gulf of Tehuantepec. It's cold air surging southward with a large anticyclone over Texas and eastern Mexico is going to be associated with a surge of cold air, which is going to pass through this gap out into the Gulf, and we'll look at it as a simulation from, well, not a simulation, a forecast from the GFS for that particular event. But really cold air streaming over the Gulf of Mexico, kind of a miserable day, I guess, if you're out over the Gulf doing any sort of commerce. Let's go back a click and first just check on a map. I have a map that's brought up in the topography right here. Good, so here's our isthmus, Mexico, the Yucatan Peninsula, and we're going to be, here's the Gulf of Tehuantepec. That's located right here. And there's a gap in the Sierra Madre Mountains that are located along this isthmus. And so as this cold air is surging southward, it's going to make it through this gap and then spill out into the Pacific Ocean. This has significant influence on helping to change the structure, I guess, of the marine environment as that cold air sweeps out. There's some upwelling that's experienced, and it makes it, it brings up nutrients for fishing, so it has a big impact on fishing there. These events typically occur between October and late February, March over this region. Again, you need a cold air outbreak from the higher latitudes. So what I'd first like to do is go to the terminal, the first tab in that terminal, not the one John was using, but the one just towards the left. And we'll type GD plot, and we'll just do run. And so what we're going to see first is a forecast from the GFS. There it is. What's plotted here is we have the winds at 10 meters with temperature, or in this case, the potential temperature that's being plotted, or no, temperature at 2 meters in degrees Kelvin, and then the isotax for the 10 meter wind. And if we type semicolon L in that, we should be able to loop it. We have to run it first, I guess, if it doesn't loop. Yep, there we go, it's looping. And so it starts off at 12Z this morning, and then it goes forward in time. And you can just watch the winds passing through that Chavela Pass early this morning. It already started, I guess, but you can see the surge. I mean, these are in meters per second, so we're looking at isotax. These are really strong winds. The winds are plotted in knots, so we have this sharp, strong gusty winds moving out over the, not even gusty, just really strong winds going through that pass. You can also see the temperatures at 2 meters in the model forecast cooling off significantly as that cold air begins to advance through the pass. So really an interesting phenomenon. The other thing that's kind of neat is if we stop this loop, just click on that, and we're going to look at the vorticity associated. You can see significant cyclonic and anticyclonic vorticity. Let's look at the size of it, what's been forecast, at least in the model. If you do restore or just res vor.set and run that.
Well, that seems really easy. It's you don't have to go to all those Python packages and whatnot.
Don't have to do all that. But you do have to use some judgment in colors, which I didn't really do well. Line equals, what's yellow, folks? 5.
5.
So line equals 5/-2/3.
In Python, you can just say line equals yellow.
True.
What'd you say?
Who would want to do that? Life has to have some complexity to it, right? So let's do semicolon L here and just loop that. Can't do that in Python. All right. Semicolon L, please. So this is showing the vorticity. So again, the vertical component of vorticity, as that surge comes in, it's really neat. You can see this sort of dipole of cyclonic and anticyclonic vorticity. Again, the winds are also plotted here. This is at 2 meters. And, a question that I would pose is, folks talk about this cold air as it surges off the coast. I guess it's drawing water away from the coast. Maybe it fosters the upwelling. but what's the significance of these anticyclonic and cyclonic and anticyclonic gyres that form here in terms of helping, and that's right above the ocean surface, is it helping to use active pumping to redistribute nutrients, I guess, in this region.
You should mention that that is the primary mechanism for tropical cyclone genesis on the west coast.
Right, so these, yeah, as easterly waves are passing south of this isthmus during the tropical cyclone season, they can get either energized or there's an interaction between what comes through this pass and these waves that can lead to tropical cyclogenesis. But just a really interesting, again, the example of this surge occurring this time of the year and just a nice manifestation of it in the model. So,
Do you know any more about the economics of the fishing industry there?
don't know much about that.
That's interesting, and I wonder if it's cyclical. Some good years where it's cold in North America, they have better fishing at the end of the winter, February,
That would
March.
be an interesting study to have that, look at the, how cold is it over the, North America, and then looking at the
Yeah.
income they generate from the fishing industry. Interesting question. So that interaction, that link between sort of weather and economic activity is certainly important. Let's click on this to stop it.
But this, in terms of the fisheries, these are short-term events. They don't necessarily last long enough to bring in a lot of fish.
Right, but I guess how many outbreaks do you get during the course?
Yeah, yeah, yeah.
So
What
a
if it's
seasonal.
repeated every 10
season.
days or something? It might be a great season compared to when we never get one.
Or like in the late 1970s, 79, and
Yeah,
77 were really
right.
cold winters over the eastern part of the United States. So go to the first second one, sorry. Second tab. Second, or third tab, I can't. Well, in Python it would be, see, that's messing me up. Zero indexing. Okay, so this is the, our meteorogram. John, welcome back, meteorogram. I knew you wanted to see this.
Yeah.
And you can see that the forecast for the weekend for us, this is the model issue, the MM5 initialized at 12Z this morning. This is looking at the temperature trace for Madison, forecast temperature, dew point, and precipitation. John's looking forward to a few flakes of snow. Maybe he would like more than that, but the model is actually forecasting a little bit of precipitation, and I'm pretty certain it's going to be cold enough for it to be in the frozen form later on this afternoon, early evening. We saw some evidence of that on the radar.
Oh boy, am I excited.
And then we get another little increase later on. So we have a couple of shots of snow. I don't know if these are going to be recorded on Ed's, the state climatologist graph with these traces, but I think those little notches there were just the days that actually had accumulated precipitation.
That's probably right.
So we may get a couple
But
more.
my memory has about less than two weeks of days of snow, so it's about the same as what you have.
You just filter out the flurries. Or no?
No, I count them all. They're all precious to me, and they don't happen.
Okay. We're a little deep here. Let's go back a little bit, look at the time height section for this. So what's happening over us? And I have a sort of a puzzle of a question here. So here's our dynamical tropopause. This is in green. You can see it dipping down. You can see also the cold dome that's going to be associated with it, and time running from left to right here. You can see as it's approaching, we get this surge in vertical motion. That's the light blue. Upward vertical motion ascent occurring as the upper trough approaches. And we do see the relative humidity is increasing as well. So this is our first shot of the snow as this comes through. You can see at the surface, the strong northwesterly winds. Winds goes from southwesterly to westerly to northwesterly as this approaches, and the cold air begins to come in with the surface trough passing by. And then, see that dome begins to rise a little bit, and we see temperatures in the mid-troposphere really beginning to warm up significantly with some warm convection occurring during this time period in subsidence. And then we get another surge as another, not as deep or as impressive a trough as when you're approaching us, and we'll see this in the forecast. With strong warm convection, and we get this broad area of increase in relative humidity, which gives our second shot at maybe a little bit of precipitation, but it looks at this point to be relatively light. And we'll see that in a couple of different model forecasts. What I thought was really interesting here is that in this layer, where you see strong westerly winds that are kind of persistent from 18Z on the 5th all the way to the end of the period, we see these isotropes going upward, more and more upward during this time period. But I don't see evidence of backing of winds with height, which would be cold advection, right, at least at this location. And so if it's cooling off here, it must mean that there's just broad ascent that's occurring. And maybe part of this is what we see here in the blue of the ascent And maybe it's just very weak ascent in a stably stratified environment that's cooling things off. I don't know if anyone has any other comments about that. It's not horizontal temperature protection, at least evident in this time height section.
Yeah, it's maybe subtle. I'm looking at the 0606 column, you know, when you're down at the 50 knot wind or the 45 knot wind that intersects the 294 isotrope, and then go all the way to where it's 80 knots. And that's, you know, that there is backing in those two winds.
It's just very
It's
subtle.
not very large, but it's there. And the wind speed increase, given that backing, might tell you something about the advection.
So that vector change, if that plotted, might be more revealing.
It might be more
than
obvious.
just what you can see with your
That's
eyes.
right, maybe.
Okay, so that's kind of an interesting.
But your idea is a good one. I mean, that's another way to cool the air. That's certainly the
And
case.
that's probably what's happening in here.
Yeah.
Okay, so we have these weather systems passing by. Let's take a quick look in the horizontal maps to just see, get a sense of what's happening. So let's go to 6 hours in the forecast, and we'll kind of step ahead with this. And we'll also take a really quick look at the precip type in the forecast over the, using another model run. But here's that significant precipitation event out in the east with a front and a weak surface cyclone that's expected to develop. This is 6 hours in the forecast. This will be valid just at the top of the last hour, with light precipitation forecasted over parts of eastern Minnesota and the western parts of our state, and maybe a weak surface trough or even weak paracyclones moving across the western parts of Wisconsin and the Lake Superior. Let's go ahead and click to tonight, 18 hours in the forecast, near midnight. This suggests a period of light snow will just been ended over our area. John will be quite pleased with that little bit of snow. That's insane, John.
Thanks.
And but the coldest air, and thickness-wise, is going to be now just to our west as that trough, or toward the east as that trough continues to move eastward, and we have warm advection already beginning to set up. With that cyclone that John noted just off the west coast of the United States, we saw is now beginning to redevelop on the lee of the Rockies and the Canadian Rockies by later on tonight. Nice strong warm advection beginning to set up. Let's go ahead to tomorrow morning. Or actually to noon tomorrow, so let's go to 36 hours. Whoa, I'm sorry, 30 hours. So this will be tomorrow around midday. We saw some evidence of low-level warm advection, warming in the lower troposphere, and here is that warm advection that's manifesting the thickness, strong thickness advection. Here is a cyclone running down along with the baroclinic zone. Maybe sort of an Alberta clipper-like disturbance,
nice
but I think it
one.
had its origins and back off the west coast of the United States just earlier this morning. And the east coast event has now moved out, and strong northerly winds in the Gulf as that cold air pours into the Pacific. So this is our next potential snowmaker. Again, this will probably track right along the region of strongest low-level warm advection, perhaps just passing to our north. This also portends for us to have a relatively warm day tomorrow, even with some clouds increasing during the course of the day. Let's go ahead to tomorrow evening. We can actually go, this will work again. So this is tomorrow night, midnight. That cyclone, you can actually see the ice tropes, or sorry, the thickness contours actually getting a little bit more disturbed, so there's a much more potent lower tropospheric thermal anomaly. You can also see the cyclone, clear cyclone has emerged over us with a broad area of light snow. Most of the snow again occurring to our north with this warm advection. And the cold front behind it probably not pass through by the time we get to Sunday morning. So this is tomorrow night midnight. Let's go to 48 hours. It's kind of just falls apart, doesn't really chugging along. This has now reached just north of Green Bay, and the front just passing through our area by the time we get to Sunday morning. With maybe some snow showers still continuing over us at that. And by the time we get to the end of the day, 6 hours further ahead, not the end of the day, but 6 hours further ahead, 54 hours, fronts to our south, northwest winds, and probably Saturday beginning to clear out. Forecast, at least in the model, was for temperatures to still stay warmer than they were today or tomorrow. So maybe this is going to, the real cold air coming back in is going to be delayed a little bit until Monday morning. So that's what we're seeing with this. A couple shots of snow over us. Let's look at, try to have this planned. Let's go to the 700 millibar Q vectors for this. We'll look at a couple different times let's go to 30 hours. Look at, and this is the period when this is for the second round of snow that's going to be approaching tomorrow afternoon. To our west, we have a nice strip of Q-vector convergence. Recall when we looked at the earlier times with the thickness contours, we saw that it was just kind of a nice northwesterly flow with a little weak wave in it. And then later on, we saw that those thickness contours began to see more of a thermal ridge. Well, the creation of that thermal ridge is going to reorient our Q-vector, so this is really going to be a lot of QS convergence along here, which indicates there's an impact from an upper wave. And if we look at this time, 30 hours of the forecast, Q-vector convergence is associated with diagnosis of ascent. Let's go to the vertical motion at 700 millibars, same time period. And that's going to be 700 at 30 hours, right? That's the time we're looking at. And you can see, maybe 36 hours it's even better, but you can see this region of ascent that's diagnosed. The strongest Q-vector convergence was near the sort of ahead of that thermal wave, and there was also some frontogenesis on the northern side of it. If you go back, if we click back to that Q-vector map, you'll see that. 30 hours, Q-vectors. Right here, so there is that frontogenesis that's occurring here, and we have this strip of, again, we have diagnosed vertical motion from this. Again, you can't look at just this one level. It's useful to look at that, but if you were to invert it, you can see it from a much, a more coherent structure that emerges from. Okay. And let's go to 36 hours, same map. And this is probably the time tomorrow evening around sunset, or just after sunset, when we're still, we might have our best chance at seeing some snowfall, provided it's moist enough for that to occur. Okay, quick back out of that. And the last thing I'd like to look at is just lower tropospheric potential vorticity, of the evolution of that. The thing that I find kind of neat on this particular map is you see these deep troughs that start off at the very beginning of the period, but this huge anticyclonic circulation, low potential vorticity air that's kind of moving across the west coast and the central part of the United States. This is something that, particularly later in the season, seems to be associated with our beginning to kind of warm up, and the toughness, if you will, of the cold air begins to relax over us as we're getting this large, broad, sort of subtropical PV type of air mass over us and at very high latitudes. So I think that's going to suggest that at least early next week shouldn't be too bad, too tough to take weather-wise. And so we'll see that air. Again, this is just looking at the potential vorticity, but, I would imagine that also means that the polar jet's going to be well to our north during this time period as well. So we look at that. And just a nice evolution of a nearly conserved variable on this map.
Yeah, you really can see the power that's stretching in the eastern side of this upper trough. Maybe we're getting too far out in advance, but when you see that PV feature get stretched from New Mexico all the way to New England at the end of it, coming up right here. Look at that. You can't do anything else but get stretched in the direction of the flow.
Yeah. So this is really the informative nature of the flow is what it shows up here. The last thing I want to do is go to the pivotal site, that may be the first or second. Click. Go to that. Click on that. And then log in. And let's go to 6 hours of forecast. So this is just kind of neat, kind of curious about, precip, when we're talking about precip types. We can just quickly investigate what's going on off the East Coast and sort of, let's click here near Albany, where they're depicting snow, the most likely focusing is snow and sleet. And you can see in the temperature structure, one, it's quite saturated all the way up until you get to about 600 millibars or so. Here's our 0 degree isotherm. And so most of this column is either at freezing or just, definitely below freezing. So you might anticipate, I'm not a microphysics person by any stretch, but I might be a Michael physics person, but there's a little pun there. This would, basically largely expect to see snowfall in this particular cell. You have this mix of precipitation types. Let's click back and look at go a little bit further into look at freezing rain. Yeah. Southeast Massachusetts. Take a sample there. We've got 2 more on that So, yeah, this is a little bit too warm, this is probably because of the rain. But you can see the, that layer being just above freezing.
Oh, yeah, this is-
Here's a 0 degree, 2 degrees of therm. So we have that layer, but again, it's solidly below freezing at the surface, but we have a layer that's fairly deep, or just deep enough, I guess, for it to be warm. So this is gonna all melt as it falls through that layer. And again, freezing rain is probably the indicated thing, or sleet if it's deep enough, cold air is deep enough. But really a nice mix of precip types off along the East Coast today.
Yeah.
We'll click back out of that. Please, Pete, and we'll go to the, just look quickly ahead, 72 hours of the forecast. 72. There's our departing weather system that gives us the snow on Sunday. This is now Monday morning, 12Z, it's out of the way. And let's just quickly step ahead, 24 hours, the 96 hours of the forecast. Here is that mild air beginning to return again. That's under that huge, large-scale anticyclonic circulation we saw in the PV structure, low PV above us. You know, so nice relaxation in temperature, at least for a few days.
Colorado is developing a high wind situation.
With the, what are the key things you'll be looking at for that?
Well, I'm looking at the buildup of the anticyclone in western Colorado, the cool air, and now they're gonna get this surge of the katabatic winds again like they did before, coming across the Rockies. And it could create regular mountain waves or katabatic winds. I don't really know if anyone knows exactly which situation produces one or the other, but I think at any rate, this situation ought to produce a surge of winds across the mountains.
Yes, well, something we'll see how that verifies over the course of the week. We'll go to 120 hours. It's a nice days, Monday, Tuesday, Wednesday. We definitely cool off into the cold advection starting. At this point, Greg, I mean, pressures are beginning to, I guess, increase on the western side of the mountains at that point. So does that boost, weaken the opportunity for those strong winds?
Pressures are decreasing in the western.
Sorry, the eastern side, sorry. I mean, these pressures are decreasing.
The gradient isn't as strong, so that, it might, but you still, even in this situation, depending on how strong the winds are aloft, you can still produce a mountain wave effect.
Okay.
That would produce a strong wind. The straight katabatic flows, I think, are more driven by that cold surge. But the mountain waves themselves don't necessarily need a big cold surge, they just need this situation, so we'll have to see. I think at any rate, if you're in eastern Colorado and you look up here, you can see lenticular wave clouds.
Okay. All right, and finally, we'll just quickly go 144, 168 hours to get us to the next weather watch. So that brief warm-up that we had is now punctuated by us cooling off again, getting a little chilly, but not much in the way of significant precipitation. So we have a few chances of snow, not much at all.
More St. Louis snow.
And then, well, it looks like a relatively quiet period over this.
Whoa, more northern Wisconsin snow.
So, anyway, well, thanks everyone for the comments, questions, good discussion on last week's storm. Thanks, Angela. Thanks, Greg. Thanks, John. Thanks, Pete, for running things. And thank you all for coming. See you next week.
Thank you, Michael. We're in the Bermuda Triangle for snow.
So Greg, I kept looking at later flight legs when they actually got onto the band, and they ran into a lot of turbulence, and then you started to see more of the but it wasn't until later on when they got into the band. So they thought it makes sense, I hadn't looked a little bit later.
It looks like a situation where the aggregates are starting off at high levels.
I don't know about this, yeah, exactly.
They're coming down, reflecting the smog. But it's not that reflecting. Not really.
It's just the sound of the
And there were a few instances I was able to pull it up on the radar. You could see a few different cells. Once they got the eruption too, so, yeah, I just had to look a few more times later and see what's going on.
It's kind of a feeder mechanism in a sense like that. But That's unusual for these courses.
Temperatures -1036, temperatures -25°C. Never saw anything other than like the ski racing.
We do welcome questions. If you have a question, or if it's a-
Yeah, we haven't.